Okay. In today's lecture, we are going to do 4 questions. Okay, 1.90, 1.91, 1.92, 1.93. 1.90 is basically a question from basics or fundamental questions. Question 1.91 is not, it's little bit difficult. Okay, question 1.91, 9.92 and 1.93 are little bit unintuitive to understand. Okay, and question 1.91 you can moderately just see it, and it's well if you understand, it's unwell if you don't. Question 1.92 and question 1.93, okay, 1.92 mostly, although it might be little unintuitive to understand, especially question 1.92, I suggest you pay attention to it, because that kind of questions have come again and again. From suppose in surface tension, that kind of questions have been repeated. So 1.92, although it's a little bit difficult, but just pay attention to it and see the generalization that I'm doing out there. Okay, or the generalization I'll be doing out there. Another lecture, another question. So, acha. So in this question, what is being said is that there is a circular orbit. Okay, in this circular orbit, a car is moving. The initial velocity of the car is equals to 0, but the acceleration or the tangential acceleration has some value. Okay, the radius of this circular orbit is 40 meters. I'm seeing this car from the helicopter. That means I'm looking down at the car from a helicopter. So I'm looking down at a ground. The car is moving in a circular orbit. Okay. And since this is a circular orbit, it has a centripetal acceleration. So wherever there is a acceleration, that means there is a force. So this car has two force. One is tangential force and one is centripetal force. Okay. But tangential force is equals to mass into tangential acceleration, where centripetal force is equals to mass into centripetal acceleration. The centripetal acceleration is equals to v square by r. Okay. Now the question is asking, starting from zero velocity, what is the distance traveled by this car before this car slides off the circular track? That means before this car slides off this circular track. So the car will slide off the circular track when the value of friction force, okay, is lesser than this value, which means, see, there are two accelerations out here. These two accelerations are nothing but representative of two forces acting on this body, tangential force and centripetal force. And who is providing this tangential force and centripetal force? The friction force. Okay, and what is the maximum value of friction force? Friction force is equals to mu into n, but n out here is equals to mg. See, n would be outside the plane of paper and mg would be inside the plane of, or inside the ground, if you are looking from the helicopter to the ground. Okay, but the maximum value of friction force is equals to mu mg. Okay, now let us find out the value of this, the combination of these two forces. So can I say net force is equals to mass into acceleration? So what is the force? Force is equals to mu mg. Are there any other forces on this plane? No, which is equals to tangential force plus centripetal force. Okay, and these forces are always a vector quantity. See, forces are always a vector quantity. Now, interesting thing about this is the tangential force and the centripetal force are always perpendicular to each other. Okay, at every point in the circle. So if you want to find out the magnitude of this force will be mu mg only. The direction will depend upon the situation of this one. So mu mg is equals to magnitude of tangential force plus centripetal force. Okay, this is the magnitude of tangential force plus centripetal force, which is the net force acting on this body. Okay, or can I cancel m from out here? I'm cancelling the m value out here. M and m will get cancelled. See, if you take m square common out here and take it outside the under root, okay, m and m will get cancelled. So After that, what do I need to find out? I need to find out the value of V. Okay, so when V has a certain value, or the value of friction force, okay, the maximum value of friction force is lesser than this value, is lesser than, that means the friction force cannot keep up with the demand, okay, of the tangential acceleration and centripetal acceleration, then the body will no longer move in a circular orbit. Okay, so out here, instead of solving with inequalities, let's solve with equalities. Okay, squaring both sides, I get mu squared g square is equals to at square plus v square, or v to the power 4 divided by r square. Okay, if I send at to the left hand side, mu square g square minus at square into r square is equals to v to the power 4. Okay, so when velocity, or mu square g square minus at square, let's leave it like this only. So when velocity is lesser than this value, that only, for velocity lesser than this value, the car will stay in this track. Okay, as soon as the velocity exceeds this value, what will happen? The car will escape the circular track. Now the next part of the question that I'm trying to solve is, okay, the car started with the initial velocity is equals to 0. The initial velocity out here is equals to 0, and there is a tangential acceleration across the surface. So at what distance will the car reach this velocity? That is my second part of the question. So can I simply apply v square is equals to u square plus 2s? V square is equals to u square plus 2as. I need to find out this value. Okay, initial velocity is equals to 0. Okay, final velocity v square comes from this equation, isn't it? So if I do v square is nothing but under root of u square g square minus tangential acceleration square into r is equals to v square. If you under root both left hand side and right hand side, will get this value. Okay, so if you put this value in terms of v square, you get r into mu square g square minus at whole square. Okay, what is the value of acceleration? The value of total acceleration is nothing but tangential component of acceleration, because when the total velocity is lesser than this value, then only the car will stay in the circular track, no? Okay, so what is the value of tangential acceleration? The value of tangential acceleration is given as 80. Okay, so you can find out the distance. So r under root of mu square g square minus at square, which is the velocity square, minus or divided by 2 into 80, divided by 2 into 80 is nothing but the distance traveled by the car before it slips off the circular path. Understood what I'm telling? Out here, the friction force that is being provided by the wheels of the car on the ground, on the wheels of the car, is nothing but the total tangential acceleration plus centripetal acceleration. Okay, so total force is equals to mass into acceleration, or total acceleration. Since acceleration is a vector quantity, we found out the magnitude. Okay, out here we have established that the velocity must be lesser than this value for the car to stay on the track. After that, what happens? After that, we apply v square is equals to u square plus 2s, where a is the tangential acceleration. Why have we used tangential acceleration on this acceleration out here and not a combination of both the acceleration? Because we need to find out this distance, no? Okay, we have to find out this distance. Let the force be whatever the value it has, and this distance will be only covered by tangential acceleration. Centripetal acceleration is only used to change the direction of the car, no? The actual change in velocity will be covered by this tangential acceleration. So this is our value of distance. If you plug in the value of mu as 0.2, okay, at as 0.62, g as 9.81, and r as 40, will get the actual answer. you'll get the correct answer. Just plug in the values, use the calculator. Okay, this is simple enough. Now this question can be solved by two methods. Okay, so first method I'll show you right now, and the second method applies a little bit of concept of mathematics. Okay, the first method is purely physics. Okay, so the question is saying I'm looking from a helicopter onto a ground. Okay, on a ground a road is made. Okay, curved road is made. The curved road follows the equation y is equals to the equation of this road. Okay, is given by y is equals to a sine x by alpha. Okay, this is the equation of the road. Okay, now a car is traveling on this road. Okay, with constant velocity v. That means the speed of the car is constant throughout the road. Okay, although the speed of the car is constant, the velocity vector, the direction of velocity vector of the car is changing throughout the road. And what is causing that change in direction of velocity vector? The centripetal acceleration. Why? Because there is no tangential acceleration. If there was tangential acceleration, this magnitude of v would change. Okay, so there is only change in direction of velocity vector, and that is being caused by centripetal acceleration at each point at that instant. Okay, whenever only direction of velocity vector is changing over time, okay, that means centripetal acceleration is there. Okay, or centripetal acceleration is changing the direction of this velocity vector. And who is providing the centripetal force to cause centripetal acceleration? The friction force provided by the ground on the wheel. Okay, the friction force provided by the ground on the wheel is causing that centripetal force, which is changing the direction of velocity vector. Okay, okay, so friction force is equals to mass into centripetal acceleration. And what is the value of friction force? See, we're looking from the helicopter to a ground. The maximum value of friction force is equals to u mg, where mg is towards the plane of the paper, normal force is away from the plane of paper, so n is equals to mg. The maximum value of friction force is equals to mg is equals to mass into what is the value of centripetal acceleration? V square by r. Okay, now the question is saying what is the maximum velocity the car will ride without sliding? That means what is the maximum velocity we can provide, okay, so that the car stays in this path. Okay, so for to design for maximum velocity, to design for let me reiterate my question. See, maximum, the question is asking at what velocity will the car ride without sliding. That means we have to find out the safest velocity. Okay, so out here, see, in this equation will give out the equation of velocity, or v square is equals to mu g r. Okay, where r changes from position to position. R at this value is different, R at this value is different, R at this value is different, R out here is different, R out here is different. So what is the maximum safest velocity? So if you are designing the safest velocity out here, mu and g is constant. Okay, so we must design for r minimum value of r. Okay, why minimum value of r? See, at each point of the curve, okay, the radius of curvature would be different. Okay, so if you design for maximum, suppose a car can travel safely with 100 km/h, and out here r has very less value. Okay, at this point of the car r has very less value. So what will happen? The friction force cannot keep up. So even if the car can travel safely out here with larger speed, the car will slide off the track out here. Okay, so we must to design for safest velocity, safest velocity. I don't know safest is a word or not. Okay, we must design velocity for minimum value of r, minimum value of r throughout the curve. Okay, Now what is the minimum value of r? At which point we would get the minimum value of r? By observation. Okay, by observation the minimum value of r is obtained at peak. By observation, minimum value of r is obtained at peak. How? See, out here. See, if you have a flat line, the radius of curvature is very large. Now I curve it little bit. The radius of curvature is little bit smaller than flat line. And if I have somewhat curve like this, the radius of curvature will be lowest where the curve is, or the steepness of the curve, where the curvature of the curve is highest. So in this graph, can you see the curvature of the curve will be highest at these peaks? So at this peak, the value of radius of curvature will be minimum. Okay, the more curvier the curve is, the lesser is the value of radius of curvature. Understood this one? So this much was obtained, where r is the radius of curvature. You have to figure out this value of r. Now when the car is out here, okay, I'm drawing this entire diagram out here. At the topmost point, when the car is out here, what is the x component of velocity? Vx is equals to v. Okay, why? Because at topmost point there is no y component of velocity. No, at topmost point it will only travel in x direction. The velocity vector would be parallel to the x component. And what is vy? Vy is equals to 0. Okay, okay. To find out the radius of curvature, you must always use a concept. What is that concept? That centripetal acceleration is equals to v square by r, the radius of curvature. Okay. Now at the topmost point, okay, vx is equals to v, or normal velocity, or fixed speed, or constant speed, and vy is equals to 0. At topmost point, what is the centripetal acceleration? Centripetal acceleration is nothing but acceleration in y-axis. Okay, so see, and what is the acceleration in y-axis? We have to find out. Okay, so our equation is given as y is equals to a sine x by alpha. Okay, what is dy by dt? dy by dt, dy by dt, okay, is nothing but d of a sine x by alpha by dx into dx by dt. We apply the chain rule out here. Okay, dx by dt is nothing but vx. Okay, and vx at the topmost point is nothing but v. Understood this much? Which is a constant. Now if I differentiate this term with respect to dx, what will happen? If I differentiate this term, it is nothing but a cos x by alpha by alpha. Okay, the differentiation of this term is this much. So let's write out the differentiation of this term out here. A by alpha cos x by alpha into, see, into v. I'm applying this v out here. Understood? This is nothing but dy by dt. What is dy by dt? Velocity in y component is equals to velocity in y component, which is equals to 0, isn't it? Say out here, what is variable out here? The only variable out here is x. A is constant, v is constant, alpha is constant. The only variable out here is x. So from this common sense, can you say x by alpha is equals to 90, or x by alpha is equals to pi by 2? Okay, So x by alpha is equals to pi by 2. X by alpha is equals to pi by 2. Okay, remember this one. Because y component of velocity is equals to 0. Now I need to find out the centripetal acceleration. Why centripetal acceleration? Because I need to find out the radius of curvature. Right? Radius of curvature is equals to v square by centripetal acceleration. Why centripetal acceleration out here is nothing but the y component of acceleration. So can I say ay is equals to dvy by dt is equals to, I have to differentiate this entire term with respect to t. So d of av by alpha cos x by alpha by dx into dx by dt. Okay. Similarly, at topmost point, dx by dt is nothing but vx, and vx at topmost point is nothing but v. If we differentiate this entire term, with respect to x, it comes out as minus a v by alpha into sine x by alpha, and out here alpha square. Okay, so this entire term comes out to be minus av by alpha square sine x by alpha, and if you multiply this v to this equation, it would become v square. Understood this much? Okay, so y component of acceleration at topmost point is nothing but this value, okay, which is also the centripetal acceleration. Okay, and what is the y component of velocity? 0. So from y component of velocity we got x by alpha is equals to pi by 2. So if we put x by alpha is equals to pi by 2, sine pi by 2 is nothing but 1. So centripetal acceleration is nothing but minus av square, or centripetal acceleration at the topmost point, av square by alpha square, and this sine x by alpha is equals to pi by 2. This entire term becomes 1 because sine pi by 2 is equals to 1. Okay, so if we put the value of centripetal acceleration out here, okay, can I get the minimum radius of curvature, and or can I get the radius of curvature? See, one more thing, this minus sign out here only determines that the acceleration is in negative y direction. Okay, so just if you just put the magnitude out here, it would come out to be okay. So out here, if you put r, or r is equals to v square by, what is the value of centripetal acceleration? a v square by alpha square, and this alpha square is going up, so I send this alpha square to the top. V square and v square will get cancelled, v square got cancelled. So r is equals to a square by, or alpha square by a. So r is equals to alpha square by a, alpha square by a. Okay, so r is equals to alpha square by a, or the minimum value of radius at topmost point is equals to alpha square by a. Now can I apply this value of r in this equation? Of course. So r is equals to alpha square by a. Okay, so if I get the equation, mu g alpha square by a is equals to v square, or v is equals to under root of, or maximum possible safest velocity is equals to under root of mu g alpha square by a, or v is equals to under root of mu g alpha square by a. Okay, now we'll do the same problem by a little bit different method. Okay, why? Because in the previous problem I said that the minimum radius would be at topmost point, so there was a lot of observation skill that was applied out there. Okay, so I want to do a generalization out here, and to be general, very general. Okay, So a car is traveling in this path, okay, with constant velocity, or constant speed, and the equation of this path is equals to y is equals to a sine x by alpha. This is y axis, this is x axis. Find the maximum possible velocity of car. So the first part of the question, where mu mg is equals to mv square by r, is same, okay. Out here v square is equals to mu g r, okay, and you have to find the value of r. Now the process becomes little bit different, and to understand this process we need to first understand two concepts of mathematics, okay, mathematical concepts or formula. The derivation of this formula will be done by your mathematics teacher. I'm just giving you the formula out here. Suppose any equation is given, any equation, this doesn't particularly work for this or equation. Any equation is given y as a function of x, okay. If someone asks you what is the length of the curve, okay, find out the length of the curve. The length of the curve is given by length of curve is nothing but under root of 1 plus dy by dx whole square, okay. I have to integrate this entire thing with respect to dx, okay, from x is equals to whatever value to x is equals to whatever value. Suppose you want to find the length from here to here, so you have to put x from here to x to here, okay. And second formula that I have to use is radius of curvature. Radius of curvature at any point in a mathematical graph, okay. The radius of curvature out here, radius of curvature out here is given by the formula r is equals to 1 plus dy by dx whole square to the power 3 by 2 divided by d square y or double differentiation by dx square. These two formulas are the formulas that you need. Understood? There is a little bit error in the formula. 1 plus dx by dx whole square to the power 3 by 2. 1 plus dy by dx whole square to the power whole square to the power 3 by 2. This is the formula for radius of curvature at any point. Okay. You need to find dy by dx, put the value of x at that point. You need to find d square y by dx square, put the value of x at that point. You have to apply this formula and you get the radius of curvature at that point. Okay, these two are the mathematical concept that will be derived by your mathematics teacher. Okay, so out here the first term we need is dy by dx and the second term we need is d square y by dx square. So the first term we need dy by dx, okay. Out here we need two terms, dy by dx, two different terms, dy by dx and d square y by dx square. So dy by dx, we have to differentiate this entire term with respect to x, or the same thing, okay. A cos x by alpha and d square y by dx square is nothing but differentiation of dy by dx by dx. That means if we differentiate this entire equation with respect to x, we get d square y by dx square, or you get minus a sine x by alpha out here alpha square. Understood? Okay. Yeah. So if we apply these two formula in this equation, we get radius of curvature is equals to 1 plus what is dy by dx, a by alpha cos x by alpha whole square to the power 3 by 2 divided by what is d square y by dx square. See, you can do minus out here. Minus. The minus out here will signify that radius of curvature. See, whatever. If the total value is minus out here, suppose you input a value of x 1, 2, 3, whatever. If the total value is minus out here, radius of curvature is minus out here. Okay, that means the radius of curvature is in this direction, negative y direction, or inside the curvature, or towards the inside of the curvature. Okay, out here radius of curvature will have positive value, out here radius of curvature will have negative value. So a square sine x by alpha. Okay, now you need to find out the minimum radius of curvature. Why? Because you have to put this radius of curvature at this position, or at this variable. Okay, this radius of curvature will be substituted out here. Okay, now to make it minimum, the denominator would be maximum. To make the denominator maximum, x by alpha should be equals to how much? X by alpha should be equals to 90 degree. So sine 90 is nothing but 1. So sine 90 is nothing but 1. So when sine 90 is equals to 1, what is the value of cos 90? Cos 90 is nothing but 0. So this entire term would become 0. So out here, r, let's not change the variable, r is equals to 1 to the power 3 by 2 is nothing but 1 by a by alpha square minus, or is equals to alpha square by a, or minus alpha square by a, or r is equals to minus alpha square by a. See, this minus signifies the direction of the radius of curvature. Okay, it will be always towards the radius. Now if we substitute this value, out here, what do we get? We get v square is equals to mu g. What is the value of r? Alpha square by a, or v is equals to under root of mu g alpha square by a, which is the same answer as before. Now a very interesting thing is that we always say no, that whenever radius of curvature comes up, you have to use centripetal acceleration. Centripetal acceleration is equals to v square by r. There is a relation between this formula and the centripetal acceleration that I'll do somewhere in the class. If I do theory based class somewhere later, I'll tell you how. Okay, so this question out here. Okay, a chain of mass m forms a circle of radius r, forms a circle of radius r. That means if the chain is like this, the radius is r. Okay, is slipped on a smooth round cone with half angle theta. So this is a smooth round cone. The half angle is theta. That means the entire angle of the cone is 2 theta. Okay. Find the tension of the chain if it rotates with a constant angular velocity omega about a vertical axis coinciding with the symmetry of axis of cone. That means if this is the axis of cone, okay, the cone rotates with angular velocity omega. Okay. So the ring that is on top of this cone also rotates with angular velocity omega. Okay, because in the question there has been suggesting that the ring does not slip over the cone, the ring rotates with the cone. Okay, so out here if I draw the free body diagram, or if I draw this diagram of cone properly out here, this is the cone. Okay, on certain part of this cone there is a ring. The ring has radius r. The half angle of the cone is how much? Theta. Okay, now the question is telling find the tension force of the ring. Okay, out here, see, what are the two forces acting on this ring? The two forces acting on this ring are nothing but normal forces and mg forces. So mg forces of this ring will always be downward. Now my second question is, what is the direction of normal forces? The direction of normal forces will always be perpendicular to the surface of contact. That means this normal force is perpendicular to the surface of contact. Okay, any body problem or any problem, the direction of normal reaction force will always be perpendicular to the surface of contact. Okay, now from this diagram, can I say, or if I draw another vertical line out here, how much is this much angle? If this angle is theta, this is a straight line. Okay, so this angle is also theta. This angle is also theta. Okay, so if this is theta, this angle is also theta. So how much is this angle? If I know this angle and this angle makes 90°, this line and this line makes 90°, and if this is theta, this is 90 minus theta, so this is nothing but theta dash. Okay, so if I draw out the forces, see, there will be two component of forces, n sine theta dash and n cos theta dash. N cos theta dash. Theta dash is nothing but 90 minus theta. Okay, Asha. 90 minus theta is nothing but, see, sine 90 minus theta is nothing but cos theta, and cos 90 minus theta is nothing but sine theta. Okay, now see, this n component of sine theta, okay, this n sine theta is balancing out the mg forces or is balancing out the gravity force. So n sine theta is equals to mg. Okay, this ring is rotating with angular velocity omega. Now let us take another perspective of this cone in another perspective. Okay, so let me erase this one. So this is another perspective of this cone. Okay, I just tilted this cone in this direction. So if I see the ring like this, okay, this is the radius of the ring. So I'm drawing the ring out here, another perspective of the ring. And the value of n cos theta is acting radially outward, no? So out here n cos theta, out here n cos theta, out here n cos theta. Similarly out here also n cos theta, out here also n cos theta, n cos theta. That means the n cos theta component is acting radially outward. Okay, and this ring is rotating with angular velocity of omega. Okay, now problem is, if the value of n cos theta is acting radially outward, this ring should expand. Why is the ring not expanding? Because there is an internal tension force of the ring keeping it together, okay, holding it together. That means the ring is pulling each other towards it. So if I analyze the elemental mass out here, suppose I'm taking elemental mass of the ring out here and analyzing it. I'm taking the elemental mass of the ring out here and analyzing it. You just imagine it is a rubber band. Okay, so this is the elemental mass of the ring that I have taken. Let the mass of this elemental ring be dm. Okay, see, this normal reaction force on this elemental ring would be upward. So normal reaction force is upward, n cos theta. Okay, so this ring should go up or expand, no? What is keeping this ring together? The tension forces from remaining part of the ring is holding it together or preventing the ring from expanding. Now the question is asking, find the value of this tension force. Okay, to analyze it, to analyze this tension force, I'll take a dm mass and draw out the forces on that dm mass. Achha, what is the direction of gravity force? The direction of gravity force is nothing but inside the plane of paper, and it is balanced by n sine theta, that is acting outside the plane of paper out here. Outside the plane of paper becomes this view. Okay, now how do I analyze the movement of this, or how do I analyze the dm mass of this or elemental mass of the ring. See out here. Does this ring has any rotation? Of course, omega. Okay. So out here, this ring has a angular velocity of omega in this direction. Understood? Now, how do I analyze this free body diagram? See, I'm erasing this part. I'm drawing this entire thing out here little bit bigger. Okay. Now, how do I analyze this tension force? See, I just drew this ring and the tension force out here. Okay. So if I draw a tangent to the ring, this line is nothing but tangent, a straight line connect tangent to the midpoint of the ring. Okay. How much is this much angle? And this tension force is nothing but tangent out here. This tension force is nothing but tangent along this line. This tension force is nothing but tangent along this line. And this line is nothing but tangent along the topmost part of the ring. Okay. So if I say this angle to be alpha, okay. Achha. If I draw a line that is connected to the center of the circle. So this is nothing but the radius of the circle. See, this dm mass was taken from a circle. If I join two lines to the center of the circle, okay, and divide the line by a perpendicular line, okay. If this angle is alpha, how much is this straight line and this perpendicular line? This straight line and this perpendicular line is 90 degree. Okay, this straight line and this perpendicular line is 90 degree. So if this much angle is alpha, how much is remaining part of the angle? How much is this much angle? Angle between this line and this perpendicular line. It is 90 minus alpha. This much angle is 90 minus alpha. So this much angle is alpha dash. Okay. And out here, if I say in this triangle, a triangle formed by the line, this vector or this line, and this line, okay, is a right angle triangle. Right angle triangle means this line is making an angle 90 degree. This line that is connected to the center along the tension, this line and this line is making a 90 degree. So this is 90 degree, this is 90 minus theta. How much is this much angle? This much angle is nothing but alpha. Okay. Now my question is, what are the horizontal component of forces? The horizontal component of forces are nothing but T cos alpha. T cos alpha out here and T cos alpha out here. Okay. Okay. What are the vertical component of forces? The vertical component of forces are T sine alpha out here and T sine alpha out here. Okay. Now see properly this diagram. The horizontal component of forces cancel out each other. Okay. Who is balancing out the vertical component of forces? The vertical component of forces was being balanced by this n cos theta that was acting radially outward throughout the ring. Okay. And this ring is also rotating with angular velocity omega. So it has a centripetal acceleration towards the center, or acceleration towards the center is equals to v square by r or omega square r. Okay. So if I draw Newton's law of motion, or if I draw the equation of motion in this line only, or this elemental part of the ring, can I say 2t 2t sine alpha, that means t sine alpha plus t sine alpha minus n cos theta okay, is equals to how much? M into a, or dm into what is acceleration, where acceleration is equals to omega square r. Okay. Now see, what is this n? This normal reaction force, this n, is nothing but, see, for this elemental ring, okay, for this elemental ring, this n sine theta will only balance out the elemental mass that is of the ring. This n sine theta will not balance the entire ring, no. The n sine theta over here will only balance this much part of the ring, so it is dmg. Okay, from this component, if we look from this component or from this component, n sine theta, 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 the n sine theta out here, this is nothing but n cos theta. The n sine theta that is towards you, okay, n sine theta that is towards you is only balancing the dm part of the mass, or dmg, because n sine theta will balance out the mass out here, n sine theta out here would balance out the mass out here. Understood? So for this much element of the ring, n sine theta is equals to elemental mass into mg, or n is equals to elemental mass into g by sine theta. Okay, if I substitute the value of n out here, I get the equation 2t sine alpha minus dm elemental mass into g by sine theta into cos theta, or cos theta by sine theta. Cos theta by sine theta is nothing but cot theta. Cot theta is equals to dm omega square r. Now somehow I need to find a relation between sine alpha and dm out here. Okay, see, if the length or if the mass of the entire ring is m, the mass of the entire ring is m, okay, so out here 2 pi r length of ring contains the mass m. If I take dm value, okay, how much angle was it subtending? The angle that was subtending by this dm value was 2 alpha, alpha plus alpha, 2 alpha, and this is nothing but r. So what is this length? This length is nothing but r into 2 alpha, r into 2 alpha. Okay, but distance is equals to, or this distance is equals to r into 2 alpha, or radius into radius. Okay, so 2 pi r length contains mass m. Okay, so unit length contains, or unit length of this chain contains m by 2 pi r. I'm just simply applying unitary method. Okay, so the length of r into 2 pi r, so r into 2 alpha contains m by 2 pi r into 2 r alpha. I just applied unitary method out here. Uh, if two mangoes cost 10 rupees, how much does one mango cost? How much does 10 mango cost? Two mangoes cost 10 rupees, one mango cost 10 by 5. So 10 mangoes cost 10 by 5 into whatever the value was. This is simply unitary method. So what I'm applying, if 2 pi r length of this ring has mass m, 1 unit of length of this ring has mass m by 2 pi r. So r into 2 alpha length of the ring contains mass m by 2 pi r into 2 r alpha. Okay, so out here, what was this mass, or what is this length? This length was nothing but dm. Okay, so out here dm is equals to m by 2 pi r into 2 r alpha. Dm is nothing but the mass contained out here. Okay, if alpha and alpha gets cancelled, what alpha? Acha, alpha and alpha doesn't get cancelled out here. Out here, 2r and 2r gets cancelled. So dm is equals to how much? m alpha by pi. Dm is equals to m alpha by pi. So if we substitute the value of dm out here, m alpha by pi, m alpha by pi, out here m alpha by pi. And notice out here, this alpha is very small. Okay, so if the alpha is very small, sine alpha can be written as alpha. So if I rewrite the equation 2t alpha minus m alpha by pi g cot theta is equals to m alpha by pi omega square r. Okay, alpha 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 gets cancelled. Okay, so out here alpha alpha and alpha got cancelled. I need to find out the value of t. So out here, if I send this entire term to the right hand side, I'll get plus m by pi g cot theta, or 2t is equals to how much? 2t is equals to m by pi, 2t is equals to this entire value, or t is equals to this entire value divided by 2. So divided by 2 divided by 2, t is equals to, Asha, can I take m by 2 pi common out here? Okay, so if I take m by 2 pi common out here, t is equals to m by 2 pi, okay, omega square r plus g cot theta. This is our answer, or this is the tension of the ring, the tension that is keeping the ring from expanding. Okay, and this problem arises again and again in your entire physics. So whenever there is a circular ring and the question is asking to analyze the tension forces of the ring, your approach should be in similar manner. Okay, out here make an elemental dm, subtend that angle to the radius or center, then draw a tangent. Alpha out here should be equals to alpha out here, and draw out the forces. Not only for this one, for any other types of, in surface tensions also there are a lot of problems that contains this kind of concept. Okay, just remember alpha is equals to alpha out here and draw out the forces. Okay, so out here tension is equals to m by 2 pi omega square r plus g cot theta. See, in this question what is being said is that there is a pulley out here. Okay, the pulley is connected to mass m1 on one end and mass m2 on the other end. Okay. So m2, this system will start accelerating when m2 is greater than m1. So the question is saying the system is accelerating when m2 by m1, okay, is equals to n naught. The ratio of masses given is n naught. That means m2 divided by m1 is equals to n naught. Okay. Now if m2 is accelerating down with a, m1 would accelerate up with a. Why? Constant motion. The length of the string is constant. So if the length of the string is constant, this much, or if this is accelerating with a downward, this will accelerate with a upward. So if I write down the equation out here, okay, out here t, out here t, but there is a mistake out here. See, usually whenever free body diagrams are given, we do t out here and t out here. Okay, tension force, if the string is same, the tension force is same. But out here the tension won't be same, because mostly when you keep the tension same, it is usually assumed that the string is frictionless, okay, and the pulley is frictionless out here. Okay, but in this question there is a friction between the thread and the pulley, so the tension out here wouldn't be equals to tension out here. So let's say this is tension T1, this is tension T2. Understood? Recall the problems of rotational motion where the pulley had some, this pulley this pulley had some moment of inertia, and you have to find out T1 this side, T2 this side, and the third equation was obtained by T1 minus T2, or T1 torque minus T2 torque is equals to I into alpha. But out here, okay, this string is sliding over this pulley. This pulley itself is not rotating. The moment of inertia of this pulley is not given. This string is sliding over this pulley, and there is a friction force. That friction force is the friction force is due to the friction between the string and the pulley. Okay, so if I write out the equation out here, T1 minus M1G is equals to M1A. This is our equation number 1. From second body, M2G minus T2 is equals to M2A. Okay, usually what is to happen is this T and this T is to get cancelled and we have to write down the equation. But out here, due to friction, T1 is not equals to T2. So how do I find out the relation between T1 and T2? To cancel out these two, but to find the relation between T1 and T2, no? So out here, if I see this block out here, this side is T1, this side is T2. If I see the pulley out here, sorry, not block, pulley. Okay, and in this pulley, the friction force is acting on this direction. Okay, if the rope is slipping on this direction, friction will always oppose the direction of motion. So if I take an elemental mass out here, okay, I'm taking an elemental mass out here and I'm drawing it out here. This is the elemental mass. Okay, I do know that this side there will be some tension. Okay, and some additional amount of tension will be in this side, T plus delta T, and this additional amount of tension is causing the difference between T2 and T1. See, one more thing I'll tell you right now. If you integrate this dt, or if you integrate this delta tension over this entire surface, okay, integration of delta T over this surface till here will give you the value of T2 minus T1. Okay, so instead of writing delta T, I'll write dt. That means it's very small, infinitely small. Okay, now if I join out here, okay, make this angle is equals to alpha by 2, this angle is equals to alpha by 2. Okay, Asha. Normal forces is acting upward and friction forces is acting opposite to the direction of motion. Okay, in previous problem, if I component this T plus delta T and T into horizontal and vertical, what will be? If this angle is alpha by 2, this much angle will also be alpha by 2. See the previous problem. So if I component this T plus delta T in this horizontal direction, it would be T plus dt cos alpha and T plus dt sin alpha. Sin alpha. Similarly, if I component the T force out here into horizontal and vertical component, it would be T cos alpha and T sin alpha. T cos alpha and T sin alpha. Okay, and this rope is accelerating towards right. The acceleration of this rope is towards right. Okay, the acha. So if I write the horizontal component of equation, let's write the vertical component of equation first. Vertical component. Okay, can I say n minus T sin alpha minus T plus dt sin alpha is equals to 0? Why? Because there is no acceleration in vertical component. So n minus T sin alpha minus T plus dt sin alpha is equals to 0. Okay, so if I take this T sin alpha plus this entire term to the right hand side, it will be n is equals to T sin alpha plus T plus dt sin alpha. Now this T sin alpha and T sin alpha would be added. It would be 2T sin alpha plus dt sin alpha. So it would be 2T sin alpha plus dt sin alpha. See, add these two. Okay, and if I take sin alpha common out here, So it would be 2t plus dt sin alpha. So 2t plus dt sin alpha, dt into sin alpha. Okay, this is the vertical component of equation. Now the horizontal component. Okay, t plus dt cos alpha, t plus dt cos alpha minus t cos alpha, minus t cos alpha minus friction force, minus friction force is equals to elemental mass into acceleration. Okay, see, the mass out here is equals to 0. See, weightless thread. So the mass of the thread is equals to 0. So can I say, so this entire terms become 0. Okay, can I bring this friction force? Can I bring this friction force to the right hand side? So it will be friction force is equals to this entire value. See, now out here, t cos alpha and t cos alpha would get cancelled. T cos alpha minus t cos alpha. So out here t cos alpha minus t cos alpha is getting cancelled. So the remaining variables are dt cos alpha is equals to friction force, or dt cos alpha is equals to friction force. Okay. Now what is the value of friction force? Friction force is always mu into n. Okay. So friction force is always mu into n out here. Okay. Now what is the value of n? The value of n from vertical component is 2t plus dt sin alpha. So if I write the value of n as 2t plus dt sin alpha, what do I get? Mu into n is equals to 2t plus dt sin alpha. Okay, now see, can I send this cos alpha to the other hand side? So sin alpha by cos alpha, cos alpha. Sin alpha by cos alpha is nothing but tan alpha, tan alpha. So dt is equals to 2t plus dt tan alpha. Now let me multiply, or dt is equals to mu 2t tan alpha minus mu dt tan alpha. Okay, let me bring this entire mu dt tan alpha to the left hand side. Okay, so out here our equation would be, see, mu t minus, or if I bring this entire mu dt tan alpha to the left hand side, it would be dt minus, or dt, sorry, plus mu dt tan alpha. Made a mistake out here. Out here it should not be minus. See, mu into dt tan alpha. So out here it should be plus. So if I bring this entire term to the left hand side, it would be minus mu dt tan alpha is equals to how much? Mu 2t, mu 2t tan alpha is equals to mu 2t tan alpha. Now let me erase this one. So I got dt minus mu dt tan alpha is equals to mu 2t tan alpha. So if I take dt common, 1 minus mu tan alpha is equals to mu 2t tan alpha. Okay, and if I divide this entire thing out here, I'm taking the t to the left hand side and 1 minus mu tan alpha to the right hand side. So dt by t is equals to how much? 2 mu tan alpha. 2 mu tan alpha by 1 minus mu tan alpha. 1 minus mu tan alpha. Okay. Now I got three equations. The first equation is t minus m1g is equals to m1a, m2g minus t2 is equals to m2a, and the third equation dt by t is equals to 2 mu tan alpha 1 minus mu tan alpha. What is the question asking? The question is asking to find out the value of mu. Okay, so let's write this equation on the next page. Now I'm solving this value out here. So dt by t is equals to 2 mu tan alpha by 1 minus mu tan alpha. Okay, I made a mistake out here. See, if this entire angle is alpha by 2, out here it would not be cos alpha, it would be cos alpha by 2. Out here it would be sin alpha by 2. Out here it would be cos alpha by 2 sin alpha by 2. Why? See, this much angle would be alpha by 2, not the entire alpha. Check the previous diagram. This angle, so this angle is alpha by 2. Okay, if this angle was alpha by 2, the tangent was alpha by 2 dash. So this angle is nothing but alpha by 2. Okay, so out here the equation would be tan alpha by 2, tan alpha by 2, sin alpha by 2, alpha by 2, alpha by 2. Okay, out here the component would be cos alpha by 2, not cos alpha. The mistake that I have made out here. Check the diagram. How am I taking component, or how are the angles related? Okay, this angle would be related to this angle. So this angle would be related to this much angle. That angle between this vector and this vector would be alpha by 2, not alpha. Okay, so out here alpha by 2, alpha by 2. Okay, now the first assumption that I'm making. Okay, at very small angles. Okay, limit theta tending to 0. Theta is nearly equals to sine theta is nearly equals to tan theta. Okay, so this elemental mass is very small, so this length is very small, so alpha by 2 is much more smaller. So can I say tan alpha by 2 is nothing but alpha by 2? So tan alpha by 2 will be converted to alpha by 2, mu tan alpha by 2 would be converted to alpha by 2. So dt by t would be 2 mu alpha by 2 divided by 1 minus mu alpha by 2. Get cancelled, or dt by t would be mu alpha divided by 1 minus mu alpha by 2. Okay, so out here if I solve this equation, it would be ln t is equals to mu alpha by 1 minus mu alpha by 2, which is equals plus some constant. Okay, now the assumption number 2 I am taking. Assumption number 2, since alpha by 2 is very small, so alpha by 2 is very small and coefficient of friction is lesser than 1, so very small number multiplied by decimal fraction would be nearly equals to 0. So mu alpha by 2 is nearly equals to 0. So therefore 1 minus mu alpha by 2 is nearly equals to 1. Okay, some of you might have the question, why am I not substituting mu alpha is equals to 0 out here on the numerator? If I substitute 0 out here, the entire point of equation would be invalid, no? So what am I solving for? Ln t is equals to 0. That would make no sense. Understood? So out here I made this entire equation 1, or my equation becomes ln t is equals to mu alpha plus constant. Okay, now To solve for this constant, we must apply boundary condition. So boundary condition 1. See, at out here this was alpha by 2. This entire thing was alpha. So if we start from out here, okay, at alpha is equals to 0, okay, what is the value of t? So at alpha is equals to 0, the value of t is t1. Okay, so substitute out here, or ln t1 is equals to mu into 0 plus constant. So the value of constant is equals to ln t1. From this equation, the value of constant is equals to ln t1 because mu into 0 is nothing but 0. So out here value of constant is equals to ln t1. So if I modify the equation, ln t minus ln t1 is equals to mu alpha. Now I must apply second boundary condition. Okay, at alpha is equals to pi. Suppose I started from alpha is equals to 0 and went to alpha is equals to pi. So boundary condition 2. At alpha is equals to pi or 180 degree, the value of tension becomes T2. At alpha is equals to pi, the value of tension becomes T2. So out here I'll get ln T2 minus ln T1 is equals to mu into alpha becomes pi. Okay, so this is the second equation I'm getting. If I modify this equation, or if I write this equation nicely, ln T2 minus T1 is nothing but ln T2 by T1 is equals to mu pi. Okay, so this is the first equation, this is the second equation, and this is our third equation. Okay, so from this equation, can I say, from this equation, can I say T1 is equals to M1A plus M1G and T2 is equals to M2G minus M2A. See, so out here ln T2 is equals to M2G minus M2A. M2G minus, I'm taking M2 common, divided by T1 is equals to M1G plus M1A. So if I take M1 common, T1 is equals to M1 into G plus A. M1 into G plus A. Okay, is equals to mu into pi. Acha. What is the value of M2 by M1 given in the question? M2 by M1 is equals to N naught. So M2 by M1 would be equals to N naught. So M2 by M1 is equals to N naught. Okay. Now our first question is, what is the value of coefficient of friction when the block is just starting to, or means the value of coefficient of friction is nothing but ln this value divided by pi, or out here 1 by pi, mu is equals to 1 by pi ln n naught G minus A divided by G plus A. So this is our answer. The value of coefficient of friction is equals to 1 by pi ln n naught into G minus A divided by G plus A. Some of you might be confused with the answer that I'm getting. See, the question was asking when the block just started accelerating. Okay, so when the block just started accelerating, A is nearly equals to 0. So our answer becomes 1 by pi ln n naught into G minus 0 by G plus 0. So G by G is equals to mu. G and G gets cancelled. So out here our answer is nothing but this one is equals to mu naught. This is the answer that is given. Okay. Now the second part of the question is find the ratio of masses. Sorry, find the acceleration of the block. So from the first equation out here, can I say T1 minus M1G is equals to M1A, okay, or T1 is equals to M1A plus M1G. See the first block. Similarly, M2G minus T2 is equals to M2A, or T2 is equals to M2G minus M2A. So if I take M1 common out here, M1 into A plus G, and if I take M2 common out here, M2 into G minus A. Okay, this is obtained from the free body diagram. See the free body diagram or diagram of the pulley. Out here there was mass M1, out here there was mass M2. So if I divide this equation by this equation, that means T2 divided by T1. So I am doing T2 divided by T1. What I am finding out? I am finding out the value of acceleration is equals to M2 into G minus A by M1 into G plus A. Okay. Okay. Out here M2 by M1 is equals to N naught. That is given in the question. M2 by M1 is equals to N naught. See out here. Ln T2 by T1 is equals to mu into pi. So out here, can I write T2 by T1 is equals to e to the power mu into pi. So if I substitute T2 by T1 as e to the power mu into pi. So out here T2 by T1 is nothing but e to the power mu into pi. So out here, let's bring this n naught down here. Okay. So A by G. Let's divide this entire thing. Always cross multiply. Okay. E u pi into G plus A is equals to n naught into G minus A. We'll isolate the G and A later. Or mu pi G plus E mu pi A is equals to n naught G plus minus n naught A, not plus, minus n naught A. Now let's bring A to the left hand side and G to the right hand side. Or e to the power mu pi A plus n naught A is equals to n naught G, okay, minus e to the power mu pi G. Or A into e to the power mu pi plus n naught is equals to G n naught minus e to the power mu pi. Or A is equals to G n naught minus e to the power mu pi divided by e to the power, or n naught divided by n naught plus e to the power mu pi. Okay, see, A is equals to, I divided this entire term by this term. I send this entire term to the denominator out here. So the value of acceleration out here is equals to A n naught e to the power minus 2 pi divided by n naught e to the power pi. This is the value of acceleration that I'll be having. Understood?